Hello, let's do checkpoint 6.16. In this checkpoint, they want us to find the length of the wire with a parameterization r of t is equal to 3t plus 1, comma 4 minus 2t, comma 5 plus 2t, and t goes from 0 to 4. Now, just by inspection, this looks like a line segment for t values going from 0 to 4. And to find the length of a line in space, we just simply find those points by plugging in t is equal to 0 and t is equal to 4 and finding the distance between 2 points. But I think we're going to do it a slightly different way. We're going to rely on the formula to find the length of a curve C, and that is the line integral of 1 times ds over the curve C. Now this S is not boldface or does not have an arrow on top, so it's not a vector, and this translates to a more familiar formula, hopefully a more familiar formula, where ds is really the magnitude of the derivative of your parameterization, and you're going to go from A to B. Now that we have that information, we can just use the formula by finding the derivative of r, which in this case, because it's linear, the derivative is going to be constant. So it'll be constant vector 3, negative 2, positive 2, and its magnitude is going to be the square root of 3 squared plus 2 squared plus 2 squared, and that's 9 plus 4 and 4, so that's a square root of 17. That the magnitude of this is equal to the square root of 17. All right, I think we are all set. We have our limits of integration. So the length of this curve C would be the integral from 0 to 4 of r of t, r prime of t, the magnitude of r prime of t, square root of 17 dt. And that's just the square root of 17 times t. And we're going to evaluate t from 0 to 4. And 0 is going to be 0, so this is just going to be 4 square root of 17. All right. Again, I would encourage you to find the two endpoints by putting in 0 and putting in 4, and then finding the length of that line segment just by pretending it's a vector and finding the magnitude, and you should get the same result. Okay, I hope that helps.